Hello everyone, welcome back to my channel. Today we are solving a very important optimization problem involving fencing and maximum area. So let's break it down step by step very simply so anyone can understand it. But before then, let us see the question that we were asked. The question says, a campground owner has 1400 meters of fencing and wants to enclose a rectangular field bordering a river with no fencing needed along the river. As you can see from this sketch, the top of the river is having no fencing. The question now says, let X represent the width of the field. As you can see from the simplified diagram. Now, what were the question that follows? A said, write an expression for the length of the field. B says, find the area of the field. C said, find the value of X leading to the maximum area. And lastly, find the maximum area. This is a grade 12 calculus question that is bordering around optimization. Next is understanding the problem. Now, we were told that a campground owner has 1400 meters of fencing. He wants to enclose a rectangular field beside a river because the river forms one side of the rectangle, so he only needs fencing for the three sides, as you can see. So therefore it only has two widths, which we call breadth, like two breadths, and only one length. The top of the river is open, but the fencing was done at the side, while the bottom, which is the bottom length, is also fenced, but the top where the river was flowing is opened. Now we are asked to let X represent the width of the field. What then is our goal? Simple. Our goal is to find the length, not only the length, the area expression, the value of X that gives the maximum area, and finally the maximum area itself. The maximum area is itself. Now let's begin with the fencing equation. Listen. Now, if one length and the two width must be fenced, then we say let the X represent the width and let the length represent X. So we can simply say the length plus 2X is equal 1400. So the equation gives me L plus 2X equal 1400. So what then do? We solve for L by subtracting 2X from both sides. So it will now be L is equal to 1400 minus 2X, meaning we are moving the 2X to your right, which will now be 1400 minus 2X. So therefore, for the first answer, which is the A that asks us for the expression, this is the expression for the length. Now the next step right, which is the step 2, is the area expression. So what then do? We write the area formula. And what is area of a rectangle? Area is simply length times width, or length times breadth. So what do? We then substitute the value of L we just found, because from this step 1 we've already find the length, which is from the expression now. So the area becomes area, which is A, is equal to length times width, which is length times L, times length times X. So anywhere I see my length now, I will have to impute that value that I got from the expression, which is 1400 minus 2x, multiply by x. As you can see here, x bracket 1400 minus 2x. And when we expand, we get area is equal to, of course, the x multiplied by 1400 would give me 1400x, and x multiplied by 2x would give me 2x squared. This is our quadratic area function. Now the next step, which is the step 3, is finding the maximum area. So to find for the maximum area, we look at our quadratic equation, which is A equal to negative 2x squared plus 1400x. What have we done here? We've simply arranged it, whereby at first the area was 1400x minus 2x squared. So to make it look like a quadratic equation which has the power of 2, so we now arrange it to be minus 2x squared plus 1400x. This then is a parabola that opens downwards, so the maximum occurs at the vertex. We use the vertex formula, which is x is equal to negative b over 2a. Here a is equal to negative 2 and b is equal 1400. So therefore my x is now equal to negative 1400 divided by 2. The value of a is negative 2, so it will be 1400 divided by 4, because negative cancel negative. So the value of my x is 350 meters. So the width that gives the maximum area is 350 meters. Finally, for the step 4 is the maximum area. Now let's find the length. We substitute x, which is equal to 350, into the length formula. Remember, the length is equal to 1400 minus 2 open bracket 350. So 1400 minus 700 will give me 700 meters. So what do? Finally, we calculate for the maximum area. Remember, area is equal to 350 length times breadth, or length times width, which is 350 multiplied by 700 to give me 244,000 meter squared, or you can say square meters. So the dimensions that give the largest possible area are: the width is 350 meters, the length is 700 meters, and the maximum area is 245,000 squared meters. Thank you for watching. If you found this helpful, don't forget to like, share, and subscribe for more easy explanation. See you in the next video. Bye.